Hello, and welcome to the Field Guides. I'm Steve, and this month Bill and I are bringing you a bonus episode about ticks. Yay! And I know what you're thinking. Didn't you and Bill already publish an episode about ticks? Wasn't that the topic of episode 19? And you'd be right. Before recording the tick episode, Bill and I reached out to a medical entomologist friend for a short interview we were hoping to insert into the episode. After everything was recorded, we realized that both segments were way too long and they would work much better as their own separate episodes. Alright, so let's get into it. This episode, I'm joined by special guest, entomologist Dr. Wayne Gall. Wayne is an excellent entomologist and naturalist. I won't go into much detail here because Wayne gives a little bit of his background during the episode. But Wayne's pretty humble, and if you'd like to read more about him, friend of the show, Gerry Rising, wrote an excellent article about him earlier this year, and I highly recommend checking that out. The link will be in the episode notes. So this is a long episode with two main segments. The first half hour follows Wayne and I sampling for ticks at Stiglmeier Park in Cheektowaga, New York. And the second half hour takes place at the Julia Boyer Reinstein Library, where Wayne goes through some more detailed information on ticks with a focus on his work in Western New York. I also want to say that Wayne and I recorded this episode in the spring, but as you'll learn during the episode, throughout his career as an entomologist, Wayne would hold off sampling for ticks until early or mid-October, meaning that the fall is also an important time to think about ticks. So without further ado, here's our bonus tick episode with entomologist Wayne Gall. I'm here with Dr. Wayne Gall. Good evening, Wayne.
Good evening, Steve.
Wayne, would you like to tell the audience a little bit about yourself, maybe about your work you did with the Department of Health and now with the Department of Agriculture?
Well, maybe I should back up even a little further. I'm an entomologist. I have my master's in entomology from the University of Wisconsin-Madison and a PhD in zoology from the University of Toronto. So I'm a bug kid who never grew up. And I've had the good fortune of sort of hitting the trifecta of entomology jobs in Western New York. I was curator of entomology for the Buffalo Museum of Science from 1989 until late 2001. And then from late 2001 until just about a year ago, the end of April 2016, I was regional entomologist for the New York State Department of Health, the Western Regional Office. So I was responsible for interacting with 17 county health departments in Western New York and doing associated mosquito and tick surveillance. So I have many years of experience as a result of that, doing field work and specifically surveillance for deer ticks in the western 17 counties of New York. Since the end of April last year, in fact May 1st to be specific, I've been entomologist identifier with the U.S. Department of Agriculture's Animal Plant Health Inspection Service, Plant Protection and Quarantine, based at the Peace Bridge Crossing in Buffalo at the head of the Niagara River. So now my entomology career has taken me to identifying and working mostly with plant pests, those kinds of things that are intercepted on commercial cargo, fruits, vegetables, cut flowers, any cargo that comes across, even personal baggage, sometimes containing items of plant and animal origin that may be subject to inspection and in many cases confiscation,
Yeah.
but also have associated insect pests. So we're trying to prevent, of course, insect pests from becoming established in the U.S. So that's my background, and since this is a sound recording, you can't see, your listeners can't see what I'm holding in my right hand, but what I'm holding is a very simple device called a tick flag. It can also double as a tick drag, and it's the same device, you just hold it in different ways, and it's a 1 meter square of bright white corduroy, and it has a dowel, a wooden dowel about the diameter of a broomstick, hemmed in the one end, and I hold the end of that dowel horizontally so it looks like a flag. It looks like I'm holding a flag on its side.
Yeah, it looks like a flag that's missing most of the flagpole.
Yeah, that's right. It's like a stumpy flagpole.
Yeah.
Just a little bit of the pole sticking.
You're trying to surrender, but your flagpole's not long enough.
Right. Yeah, I wouldn't be able to get it very far over my head, that's for sure. In using this as a flag, which is the technique that we use for doing surveillance for adult deer ticks, in this case we'd be looking for ones that have overwintered from last fall. We take the flag and brush it vertically against vegetation, usually along the edges of trails, and if there are ticks questing, which means searching for a host, they'll reach out with their spiny little legs and grab onto the the little hills and valleys of the corduroy fabric. And when we did surveillance, we had a standard protocol of walking 10 meters or 20 meters, and then stopping, picking any ticks off, recording the number of meters we walked, and then continuing on. And this would actually give us a measure of the number of ticks per square meter.
Oh, yeah.
So I'm holding the flag vertically, and I'm now going to begin to brush it by swiping back and forth along the taller vegetation right at the very edge of this woods in Cheektowaga. So I don't know if you can hear on the mic that swishing sound, but that swishing sound is the sound of the corduroy fabric brushing and rubbing against the vegetation. And today is a beautiful sunny day. It's probably mid-70s Fahrenheit, and there's just a very faint or light breeze. It's bright and sunny. If there are ticks in this area questing, we should have almost ideal conditions to find any overwintering females. Having said that, if we would have done this last fall, beginning in early October, we probably would have had even a greater likelihood of finding adult deer ticks. Right now, we're just looking to see if there are any here that would have survived the winter. And they do survive the winter, many of them quite well, without feeding.
So I have a question about that. You said that in terms of weather, you said today was a nice warm day, and that would maybe be an advantage to us?
Yeah, if it's warm and sunny, they're going to be more active. You know, there's more host activity, and therefore there's more host-seeking activity on the part of the ectoparasitic ticks. Now, I just walked with you maybe about 10 meters, and I'm just checking the flag, and there's a few small insects, a few small beetles, but I don't see a single tick.
No.
So we'll keep trying, though.
So why did you say that last year you would have more luck than we might have this year?
Well, deer ticks have a 2-year life cycle, and near the end of that 2-year life cycle, they're in the adult stage, and the adult stage does not become active, does not start questing for hosts, amazingly, until the weather starts turning cool in late summer, early fall.
Oh, okay.
And so for all the years that I did tick surveillance with the state health department, we would never even bother starting tick surveillance in the fall until after the 1st of October. And in some years, when it stayed unseasonably warm through the first part of October, we'd even have to wait a week or two and maybe start more towards mid-October.
Wow.
So deer ticks are amazingly cold hardy. I remember visiting a surveillance site in the southern Finger Lakes, specifically Watkins Glen State Park, and I remember it was a very chilly morning in November, and when my assistant and I arrived at the surveillance site, was right around 32 Fahrenheit. It was right around freezing. I said to my assistant, Keith Tober, I said, Keith, I'd be surprised if we're going to find anything today. And in the first 10 meters, I had about 10 deer ticks.
Holy cow.
So they look for a host at surprisingly low temperatures.
Wow.
Which is why those ticks that don't find a host in the fall, when the really cold weather comes and snow cover, they'll actually hunker down in the leaf litter under the snow.
Yeah.
And if we have one of those unseasonably mild warm spells in the winter, say, I remember specifically several years ago in early January, we had temperatures that got up in the high 40s, early 50s Fahrenheit. About the first week of January, I was getting ticks in for identification.
Wow, okay.
So again, what we're seeing now, or could see now, if the deer ticks are established at this particular site, are those overwintering adults that emerged last fall.
Wow.
And have maintained themselves, potentially, over the winter, just waiting for the conditions to improve where they could begin host seeking again.
Wow.
So the numbers, of course, there's probably some attrition over the winter, because not all overwintering ticks survive. Ironically, you might think, well, if it's a really cold winter, are ticks less likely to survive? Well, in general, when you have continuous snow cover, ticks and insects, and of course ticks are not insects, they're arachnids, but ticks and insects that do overwinter as adults have actually a better chance of surviving under conditions of snow cover because they're insulated. So winters where there is a lot of open ground, not a lot of snow cover, or a lot of freezing and thawing, so that there's intermittently a lot of open ground, those are probably the worst for ticks. And you would think the opposite. You think if it's mild, there's greater chance of survival. But if they're quiet underneath an insulating blanket of snow all winter and then become active once that snow cover is gone, it's probably better for them.
Yeah, that actually makes a lot of sense. Bill and I actually did a subnivean zone episode, and that's one of the things we talked about with climate change. You kind of lose that insulating layer of snow, so you think of warmer air temperatures actually lead to colder soil temperatures.
That's right.
Yeah,
that's right. Because in a lot of situations where there's good snow cover, you don't have to go down very deep from the surface, and you'll get at freezing or even just slightly above freezing temperatures. So again, it's a little counterintuitive. But so people will say, oh, if we have a really long, cold winter with a lot of snow, that's probably bad for deer ticks. And I'd say, no, it's actually just the opposite. And if you need another further model for how cold hardy deer ticks are, keep in mind that there's a well-established population of deer ticks in the upper Midwest of Wisconsin and Minnesota. And trust me, the temperatures are more extremely cold there in the winter than they are in western New York.
Oh, wow.
Again, I know that firsthand because I lived in Madison, Wisconsin for 2 years. We didn't get as much snow as Buffalo generally, but definitely colder temperatures in the winter. So we're continuing along here. I'm actually doing sort of a combination flag and drag, sort of putting the flag more horizontally on the ground against the vegetation, increasing the surface area of contact with the vegetation, hoping that we might pick up something. And actually, for us wanting to demonstrate that ticks might be here, that's a good thing, but if they are here, in a way that's bad, because that means there's a risk of being bitten and, of course, a risk of being exposed to tick-borne diseases like Lyme disease.
Do you have any insights into the spread of ticks or the spread of ticks that carry Lyme disease or Lyme disease in general that you've picked up on through your time as an entomologist?
Well, I'm hoping a little later I can pull out my laptop and show you some data. The distribution of deer ticks has definitely increased in recent years in western New York. We began finding deer ticks at more and more places, and in those places where we found them, often in greater numbers. And also some of the infection rates for the bacterium that causes Lyme disease, Borrelia burgdorferi, has gone up substantially in recent years. And again, I can show you some of those numbers a little later.
Yeah, for sure. We're at Stiglmeier Park right now. We didn't say that in the beginning, but do you think maybe if they try to do some type of insect control on the field, I don't know what they do here necessarily, but do you think that's maybe why you might have more luck at Reinstein right next door?
Again, I don't know what horticultural practices they carry out here, if they use any lawn pesticides or not. I guess I'd be surprised if they did.
Okay.
I think if we maybe go in more towards the edge of the woods, we might have a better chance of finding them.
Okay.
So we can try that too. So
I guess it's time to tuck our pants into our socks then.
Well, we can walk back and go to the trailhead and then maybe walk down the trail.
Okay, yeah.
So now we're walking along the edge of a gravel trail at Stiglmeier Park Lawson Nature Trails in the town of Cheektowaga. And I'm flagging the leaf litter. Again, it's sort of a combination flag drag. I'm starting out with the flag vertically and then sweeping it horizontally over the leaf litter and the adjacent vegetation. And we're right at the edge of a very nice beech maple forest that's relatively mature. There's a fair bit of intermixed black cherry and yellow birch. So this is a pretty high quality medium to old growth forest. And of course, as everyone from this area is aware, there's also a relatively high deer population here. And although deer ticks certainly don't require deer exclusively, they are important in the reproductive success of adult deer ticks. People need to understand, though, that even if you greatly reduce the deer population, you would still have deer ticks, because especially the immature stages feed primarily on small rodents, especially white-footed mice. And in fact, it's white-footed mice that are the so-called reservoir for the Lyme disease bacterium. In the study of disease transmission and relationships called epidemiology, the white-footed mouse is referred to as the reservoir. That's the place in nature where the infectious agent resides, and it's just picked up by a blood-feeding tick who during its early stages will feed on an infected deer mouse.
Wow.
So here we have bingo.
Nice.
We have three ticks.
Okay.
1, 2, 3. And based on the very dark color and the relatively small size, those 3 are males. The females are a little bit bigger, and they show a little more orange color on the top surface of their body. So we probably just walked along maybe 10 or 15 meters, and again picked up 3 deer ticks, adult males, just in that period. So right now we're looking at 3 male deer ticks crawling across this flag. So
wow.
Again, we're in good deer tick habitat.
Yeah. So even after whipping the flag around, they were still stuck onto the...
Two out of the 3 males were still hanging on to the corduroy, even after vigorously shaking it, like snap shaking it about 3 times. So yeah. It goes to show you how firmly these do hold on to a host.
Yeah.
And of course, this is a poor mimic of the fur of a mammal or the feathers of a bird, but it works. So
yeah.
Okay, let's try again, see if we can find a female.
Yeah, so it was a false alarm on the last one. It was just 3 males.
3 males,
yeah.
And the males are distinguished from the females by being a bit smaller, and the entire, or virtually the entire top or dorsal surface being a uniform dark, sort of blackish brown. That uniform blackish brown color is because of a sclerotized plate, a hardened plate called the scutum, which covers virtually the entire top or dorsal surface of an adult male tick, but only covers about 1/3 to 1/2 of the dorsal surface of a female. And the part of the dorsal surface behind the scutum of a female is an orangey color, and that orange color usually sticks out pretty well. And of course the female is a bit bigger. If you had a male and a female side by side, the difference is actually pretty obvious. The hard part is when you have what we just had, 3 males.
Yeah.
So you don't have the
nothing to compare it to.
The benefit of using comparative biology.
Yeah. So why is there that sexual morphology there?
Well, yeah, that's a good question, and I think there's actually a very good answer that is functional. It's a functional answer. Adult male deer ticks engorge very little at all. Their primary interest as an adult is to crawl around, find a host, and go on the host, and maybe only intermittently.
Whoa, a red tail right in front of us.
We had a red-tailed hawk just fly literally about 8 feet in front of us.
And he's still about 30 feet away.
Yeah.
Wow.
He's perched facing towards us, and you see that beautiful dark belly band.
It's not like we were being quiet or anything.
No. No.
Wow.
That hawk is hunting, and good for him or her.
Yeah.
Take all the mice that you want, because those again are the reservoir for the deer tick.
Yeah.
So anyway, getting back to the question, why the scutum of a female is shorter than the longer scutum of the male. The males blood feed very little, if at all, and when they do feed, it's intermittently, probably very small volume. They're primarily looking for a mate on a host, and so they're crawling around looking for a mate. And the females, on the other hand, need to take a blood meal to mature a batch of eggs, and that hardened plate basically is a constraint against becoming fully engorged. So by having a reduced scutum, a shorter scutum, it's easier for the adult female to become fully engorged with host blood.
Wow.
And in fact, if you were to compare a fully engorged adult female deer tick with a completely unengorged female deer tick, you'd be hard-pressed to think that they're even the same species. The size difference is so amazing. So we're continuing on here. If we maybe get into those May apples a little bit.
Yeah.
We have May apples coming up through the leaf litter of this nice beech maple forest. Maybe we'd have a better chance of finding some females. Because again, the adults like to crawl up vegetation, and that's why when you're out in nature, if you're at a location that has an established hiking trail, like this gravel hiking trail, as long as you stay on the gravel trail and aren't walking through the vegetation, you really don't have any possibility of deer ticks, because they do crawl up low vegetation when they quest or search for a host. So that's one very simple common sense prevention strategy is to try to minimize your contact with vegetation. And of course the corollary to that is if you're out walking your dog, and dogs are the perfect tick surveillance tool because they're hairy and they're low to the ground, and they like to go through vegetation.
Yeah.
You have to do a tick check of your dog once you come back inside if the dog goes through vegetation. So let's pause here and see what we've found. We probably did another 20 meters, and lo and behold, we have another male.
It's a very small one there.
And there's a female.
Nice. We had that comparative biology there because the male's so much smaller.
Yeah, so if we get them side by side, which we can do by wrinkling up the corduroy here, let's go over on the gravel trail.
Oh, yeah.
See the difference in size? And
yeah.
See how much orangier the female is?
Oh yeah, you can really see that.
Remember what I said about looking on the back side of the flag?
Yeah.
Here's a male crawling up the back side.
Oh, yeah. Yeah, so we got to be careful about making sure we look at the back side of the flag too.
Right.
Wow, that's great.
So there's a male and a female side by side, and you can see the size difference and the fact that the scutum of the female is shorter, so it shows some orange color.
Yeah.
So again, another 15 or 20 meters of flagging, we came up with 1 female and 2 males, so another 3.
Yeah.
So as you can see, the deer ticks are established at this location. So if people are walking and hiking here, you want to take precautions to minimize ticks crawling up on you and potentially biting. And not all ticks, of course, are infected with infectious agents. It's like Russian roulette, but why take a chance?
Yeah.
You just want to avoid tick habitat as much as possible. And if it is unavoidable or you have no choice but to go through tick habitat vegetation, then when you get inside, you want to do a thorough tick check, especially at the time that you take a shower. And you can also check the nether regions of your body.
Yeah, I also read that it's good to have a mirror on you, a handheld mirror.
Yep.
So you can see those hard-to-see places.
That's highly recommended. Or if someone who might be available could also do a visual check of your backside, which you can't see unless you use a mirror.
Yeah.
So tick check is important, however you accomplish that. The other kind of prevention strategies to keep in mind, especially again if you have no choice but to walk through vegetation, is to tuck your pants into your socks so that the ticks can't crawl up underneath your pant legs. And I like to wear white cotton socks so that the darker deer ticks show up quite well against the bright white socks. And also I like to wear light colored pants. I like to wear nylon pants that are like a khaki color, again because the dark ticks show up quite well.
Yeah, that makes so much sense. It's not something I thought about at all. In fact, most of my stuff is very dark.
Yeah, so light-colored clothing, especially pants and socks, is a really good idea. And tucking the bottom of your pant legs into the top of your socks is an excellent idea so that it increases the probability of visualizing a tick if it's crawling up the outside of your pants rather than getting underneath the cuff and walking up on the inside where they might attach to the back of your knee or in the groin area and you're not aware of it.
Yeah.
So now I'm going to take the flagger drag and use it in dragging mode, which means putting it flat against the leaf litter and pulling it by the string across the leaf litter. I'll maybe go about 10 meters. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And in that particular 10-meter stretch, we found 1 female.
Oh, nice.
So you can see that this is a relatively productive site for deer ticks. And 1 female in 10 meters, that's pretty good. If that was to work out on average, you could have 10 females in 100 meters.
Yeah.
So you get the idea of how abundant they could be. And that's probably pretty close to the density here because I did 15 or 20 meters each of the last 2 times and collected 3 deer ticks both times. So there's a little bit of consistency there.
Yeah.
So it works out to maybe 1.5 deer ticks per 10 meters.
You want to just do a quick demonstration of the flagging?
Flagging? Sure.
Yeah. Oh yeah. Let's find some vegetation.
Yeah, we have to find something to flag against.
Let me tuck my pants in this time. Now that we know.
The deer browse in here.
Yeah, I know. Not much of an understory. What about something like grass, like over there?
Oh no, that's good. Any kind of short vegetation, like grasses or low scrubby shrubs, those are all good possibilities. Except thanks for the deer browsing here, there's very little vegetation in the understory.
Yeah.
I mean, not to mention that this is also a relatively shaded woodland, but I'm sure the deer have much to do with the lack of ground vegetation. So we're going across the boardwalk in a wet area here, and this would not be a productive place. Deer ticks don't really like wet areas very much.
So they like vegetation and they like dry.
Yep,
right?
Dry upland woods. And probably the most productive woods to flag or drag, if you have that particular forest type, is an oak, pine, oak hickory woods, because there's a pretty good correlation between deer tick occurrence and density and the presence of oaks, which of course produce acorns. And acorns are food for white-footed mice and other small rodents, which are the reservoir hosts.
Man, it all comes back to those white-footed mice.
It all comes back to mice. The small rodents are really important in the epidemiology of Lyme disease, and also anaplasmosis and also babesiosis. In fact, a deer tick potentially could be co-infected or tri-infected with all three pathogens at once. And this has been demonstrated by testing ticks. Occasionally you will find one that has a triple infection. So,
wow.
I mean, talk about triple jeopardy.
So in preparation for this episode, I did a lot of reading on the CDC about ticks and the diseases that they can carry. Mm-hmm. Some of those diseases are kind of scary. I mean, well, I necessarily wouldn't want any of them.
You don't want any of them,
no.
Really. Yeah.
Some of them seemed a little mild. Others seemed pretty bad.
If left untreated.
Yeah.
The one good thing about Lyme disease, if there is any good thing about it, and again, it's sort of health management good, is that if a person is diagnosed with early stage Lyme disease and they're treated with the appropriate antibiotic, there's usually complete recovery.
Yeah.
So that's the one good news. It is a bacterial infection, and it does respond well to the antibiotics that have been shown to be effective. Okay, so now we're in an area where there's a little more vegetation development. So I'm going to take the flag/drag and use it in more of a flagging format against the vegetation such as it is here, present in limited abundance. But here's a pretty good stand of some wild roses.
Normally would these transects be randomly chosen?
Yeah, although you usually pick locations that have this kind of vegetation development, so you increase your chances of finding ticks. So it's maybe not completely random.
Yeah.
But you could do a completely random survey if you want, but we always try to increase our likelihood of finding ticks so that we can determine percent infection rates.
Because you're not looking necessarily at abundance, you're looking at infection?
Well, from a public health standpoint, infection rate, or minimum infection rate, is a really important metric, because that gives you a good sense of the risk of acquiring a tick-borne disease. Density is also important too, and that's why we keep track of the number of square meters that we would flag or drag. Yeah, notice the much greater vegetation development inside the deer exclosure.
Yeah.
I wish we could actually get in there, because we probably have a greater likelihood of finding deer ticks in that more well-developed vegetation. So actually I'm still going into more combination flagging and dragging here because the vegetation is so sparse. So we'll see what we find here. Even little clumps of grass like that is all you need to quest, as we say, to quest and look for a host. Okay, let's see if we've got anything here.
Okay.
And we do.
Oh yeah, it's kind of big.
We have a female. We have one adult female. And again, that was probably, 10 or 15 meters. I didn't count. Mm-hmm. But there's another adult female deer tick. So again, it's sort of speaking to the average that we saw a little bit earlier. Yeah. This technique demonstrates a couple of things. First, that it works.
Yeah.
Second, that deer ticks are found here. And because we were able to see side by side an adult male and adult female, you can see the difference in size, with the females being a little bigger and the females having a little more orange, because the hardened plate or scutum only covers about a half or 2/3 of the top or dorsal surface, showing some orange color behind.
Yeah.
So we were looking at the adult female on the drag, and she was waving her legs, her front legs, up in the air, sort of waving them around. And that behavior is called questing behavior. She's trying to sense or find a host, finding fur in the case of a mammal or feathers in the case of a bird to crawl up on. It's always interesting to see the ticks stop and actually sort of sense their environment by waving their front legs around. And of course, when the adult female or adult male crawls up low vegetation, that's what they're doing. They're resting with their front legs up in the air, outstretched, waiting for a potential host to come by.
Wow, that was great to see. I just loved seeing it. Kind of daunting too. It's waiting to crawl onto you.
Well, yeah. Well, it's sort of the real object lesson for how they find a host. So
yeah.
It is interesting.
I'm glad we got that video of it.
Mm-hmm.
At this point, Wayne and I headed to the Julia Boyer Reinstein Library. But if you're interested in watching the video of Wayne and I sampling for ticks, you can find it on our YouTube page, and there will be a link in the episode description. Now back to the show. Okay, guys, so Wayne and I moved indoors to escape the ticks because he had a little bit more information he wanted to share with us. And where are we again?
We're at the Julia Boyer Reinstein Public Library, just about half a mile east of Stiglmeier Park Loss and Nature Trails. And I'm referring to a PowerPoint presentation that I put together over the last few years when I was still with the State Health Department regarding Lyme disease and the deer tick. And there are actually three main disease agents that the deer tick can transmit. The bacterium that causes Lyme disease is one of them, but also an anaplasmal organism that causes a disease called anaplasmosis, actually an Ehrlichial organism, which is intracellular parasites related to bacteria. So anaplasmosis is a second disease that's caused by the deer tick, and the third is called babesiosis. And babesiosis has only been detected in the western 17 counties once as of at least a year ago. Anaplasmosis nowhere near as common as Lyme disease. So Lyme disease by far is the most important. And I want to give you a sense of the number of human cases of Lyme disease in western New York. And so I actually have a table that compares the numbers of cases of Lyme disease in New York State versus the United States for the period 2009 to 2013. And on average, there's somewhere in the neighborhood of between 4,000 and 5,000 cases of human Lyme disease in New York State every year. The actual case numbers that I'm looking at are a high of 5,651 in 2009 and a low of 2,998 in 2012. So again, roughly between 3,000 and 5,500 is the range. And if you compare that to the total number of cases in the U.S., New York State has about 1/7 to 1/10 the number of Lyme disease cases of the entire United States.
Is that just because Lyme disease is limited to a certain number of states, or is New York State very high in general?
Well, Lyme disease is certainly restricted to a certain number of states, and New York happens to be one of them. The big clusters of Lyme disease cases are in the Northeast, especially the Atlantic coastal states, including the southern New England states down to Virginia, and then going west through New York and Pennsylvania. And then the second big cluster is in the upper Midwest, Wisconsin and Minnesota. And then there's a slightly different cluster, obviously geographically separated on the West Coast. So there's principally three main clusters of Lyme disease cases, and New York State happens to be in the big northeastern cluster, separated a bit from the cluster in the upper Midwest of Wisconsin and Minnesota.
And we make up 1/7 to 1/10 of all the Lyme disease cases.
Yes. Yeah. For example, in 2009, when New York State had 5,651 cases, there were 38,468 nationwide. So again, roughly a seventh. But you also need to understand that even within New York State, Lyme disease is not uniformly distributed. In fact, one of my favorite graphics shows the change in Lyme disease cases through time in New York State. It shows that in the mid-1980s, about half of the Lyme disease cases in New York State were found on Long Island, and the other half were in the counties immediately outside of New York City. And if you fast forward, let's say to 2012, there were actually more cases in counties other than the counties immediately surrounding New York City than there were those New York City area counties in 2012. So the distribution of Lyme disease cases has really changed over time. So upstate New York is much more impacted now than it was, say, in the mid-1980s, when there was virtually no or very little Lyme disease in western New York and elsewhere in upstate New York. And probably the further you were away from Dutchess and Columbia and Westchester, Putnam, Rockland, and the 2 counties of Long Island, probably most of the cases in the mid-1980s that were, quote, from elsewhere in New York State were the result of travel history to those areas.
Wow.
Or to one of the New England states like Connecticut or Massachusetts or Virginia. So anyway, Lyme disease is not uniformly distributed in New York State. There are certainly many more cases even now in the Hudson Valley in eastern New York than there is in western New York. Again, this is not the kind of graphic that lends itself to verbalizing, but there's a couple of diagrams here that gives you an idea of the size of even adult deer ticks. The female is about the size of a sesame seed, and the male is just maybe 1 1/4 the size of a poppy seed. And those are the adults.
Yeah.
You can notice that the nymphal deer tick is about the size of a poppy seed, and the larva, which is very pale straw-colored, is only about half the diameter of a poppy seed. So we're talking about creatures that are pretty small. So you can see how it would be easy for, especially the nymph stage, to crawl on a person, attach, and blood feed, and the person wouldn't detect it because it's so small. It certainly is visible to the naked eye, but it's small.
Yeah.
And there's one other really important point. Well, there's probably several points to make, but one of my favorite points to make relates to the time of the year when there are the most Lyme disease cases. And this graphic shows a typical bell-shaped curve with the peak of the bell, the highest number of cases in the months of June, July, and maybe just the first part of August. That's the time of the year when the maximum number of Lyme disease cases occur nationwide. I think the sample size is like 80-some thousand, so this is very good, reliable data. But what's interesting is not only the fact that you're more likely to acquire a Lyme disease case during the months of June and July, but to overlap that with a bar graph that shows the time of the year when the different stages of deer ticks are active, and that peak in the number of human Lyme disease cases corresponds almost precisely with the peak activity period of deer tick nymphs.
Yeah. So I'm looking at the abundance of adults right now, and it looks like it's bimodal. So in June, are the previous year's ticks, are they dying off?
They are dying off. I've collected adult deer ticks as late as the second, maybe at most the third week of June, but by and large, by the end of June, the adults have all died out. And the bimodal peak is really one continuous population that's just separated by winter months. The number of active ticks from March through June is just a continuation of the previous fall's cohort.
Yeah.
It's just that the cold temperature and the snow reduces their activity to basically zero. And
so it's not truly bimodal. It's just that we're looking at it from January to December instead of from October to May or to June.
Adults that emerged in late September, early October, the previous fall, are the same ones that we would be seeing now. They're just the ones that did not find a host last fall and successfully overwintered and are coming out of hibernation or seeking hosts again. So there is a period in late May, early June where you do have the potential of not only encountering the remaining few deer tick adults that are still around, but the beginning of the buildup of the population of deer tick nymphs. So probably June is the time you'd most likely encounter both stages, but by July and August, it's virtually all nymphs, and that's the time of the year that people have to take the maximum amount of precautions, and correspondingly, those are the times of the year when people are most active outdoors.
Yeah.
So unfortunately, it's a bad correlation between a potential deer tick exposure and the period of the year when the stage that's most responsible for transmitting Lyme disease is active, that being the nymphal stage. But this correspondence in the peak period of activity of nymphs in June, July, and August corresponds very nicely with the maximum number of Lyme disease cases nationwide. So I find this to be very informative.
Yeah, that's excellent. That's a great graphic. One thing that I'm definitely taking out of this whole experience with you is that man-made paths are actually pretty incredible. One, for concentrated impact, so we're doing less damage to the environment, but two, so we're not really encountering ticks if we stay on the path, and if we teach our dogs to stay on the path as well. Exactly.
And the take-home message there is you can avoid all of this if you stay in the middle of a gravel path or a wood chip path or even an earthen path, and just try to avoid going through vegetation. And, of course, the same with your pets.
Yeah, Bill and I are really bad at doing that, though. We go off path all the time.
Well, I know. And I'm a naturalist, so I do too. So we're all subject to that.
Yeah.
I wanted to show you the most recent surveillance results that I had from the period when I worked for the New York State Department of Health, and specifically surveillance at Erie County sites most recently. The most recent data that I have for adult deer ticks is from October through November of 2015. And during that period, myself and two assistants with the State Health Department did surveillance at 9 different sites in just Erie County. And many of them were county parks, natural areas, nature preserves. And deer ticks do occur in Erie County. I mean, here we have them at 6 out of 9 sites that were surveyed. And at the sites where deer ticks occurred, some of the sites harbor ticks that are infected with the bacterium that causes Lyme disease. So if someone tries to tell you that Lyme disease and deer ticks do not occur in Western New York, here are actual data that don't back up that claim.
Wow, okay.
But keep in mind that you need both small mammals and medium to large-sized mammals for the 3 different blood-feeding stages of the deer tick. The larval stage almost exclusively feeds on small rodents. I don't think I've ever had a larval tick come in for identification that was removed from a person. The nymphal deer tick, though, does feed on small mammals, but it also will feed on medium to large-sized mammals, including people, dogs, skunks, possums, foxes, and so on. And, of course, the adult deer tick is really more focused on medium to large-sized mammals. And white-tailed deer is sort of the poster child, or poster host, if you will, for the deer tick. But keep in mind that the white-tailed deer is not the only medium to large-sized mammal that the so-called deer tick feeds on. In fact, to an entomologist, those of us who are bug geeks and actually pay attention to the fact that the Entomological Society of America publishes an official, quote-unquote, list of common names, you won't actually see the name deer tick used by the Entomological Society of America. The official common name that the ESA has adopted is black-legged tick.
Oh, okay. I think I saw that on the CDC.
So black-legged tick and deer tick are just one and the same. It's just that the bug geeks know the species as the black-legged tick, and the rest of humanity knows that tick as the deer tick.
Right,
but it's one and the same. Ixodes scapularis.
Scapularis.
Yeah, the genus is Ixodes and the species name is Scapularis.
Mm-hmm.
And there's additional confusion with naming because the bacterium that causes Lyme disease is in the genus Borrelia, and sometimes in the technical medical literature you'll see Lyme disease referred to as borreliosis.
Oh, yeah.
So it's a disease caused by Borrelia, which is the bacterium transmitted by the deer tick. So there's some name game stuff for you.
Yeah.
To give you another example of data that sort of corroborates the occurrence of Lyme disease cases in Western New York, I have a very simple table that shows the number of Lyme disease cases just in the 17 counties of Western New York. So this obviously leaves out Central New York and the Finger Lakes, and this leaves out the Hudson Valley and Eastern New York. So just in the western 17 most counties, I'm looking at a very simple matrix that shows the number of human Lyme disease cases between 2010 and 2015 in the western 17 counties. And the numbers have gone up generally consistently. There was one exception in 2014, but the numbers went from 59 cases in 2010 to 95 cases in 2011 to 116 cases in 2012, a big jump to 272 cases in 2013, back down to 217 cases in the year 2014, and then back up to the highest number of cases we've ever had in the western 17 counties, 305 cases at least as of 2015.
Wow, so even though 2014 looked a little bit better, there seems to be a general pattern of it being on the increase.
Yeah, there's a general pattern of increase in the number of cases.
Wow.
This is all based on the same case definition, so you can't say that this data is confounded by different epidemiological case definitions. Those numbers are a combination of what are called confirmed and probable cases, and each of those two case types has its own specific criteria. So it's reasonably good data. Is there uniformity in reporting? Well, it could vary from year to year depending on, well, first of all, Lyme disease is an officially notifiable disease. Any physician who diagnoses a case of Lyme disease is required to report it to the New York State Department of Health, who then also reports it to the U.S. Centers for Disease Control and Prevention. Assuming that physicians are as diligent in reporting their cases every year, then this data shows a clear trend, increase. But the interesting thing, the more specific interesting thing that I wanted to show you, and maybe we'll leave it at that unless you have further questions, the Erie County Health Department specifically looked at, in detail, 24 human cases that occurred in the county of Erie, just the county of Erie, between 2005 and 2009. And they interviewed the actual people who were the cases in question. And they interviewed 24 people. And 8 out of those 24 people on interview had no record or history of travel outside of Western New York. So that suggests a 33% locally acquired infection rate.
Right, it has to be here because they didn't leave here.
They would have had to acquire the Lyme disease infection here, the Borrelia infection here, because they didn't have a travel history outside of Western New York.
Mm-hmm.
What's interesting is the Erie County Health Department did a very nice job in doing a survey of dogs from veterinarians during the same period, 2005 to 2009. And I won't bore you with the individual numbers, but over that 5-year period, there were a total of 388 positive Lyme disease or Borrelia positive dogs in the county of Erie. This is a serosurvey, so the vet would draw blood from the dog and have it tested to show antibodies to the Lyme disease bacterium. So this is based on antibody detection in dog serum. Okay. So there were a total of 388 Erie County dogs that were positive for antibodies to Borrelia over the period 2005 to 2009. And interestingly, again, the individual owners of the dogs were interviewed, and 127 out of 388 reported no history of travel for their dogs during that period, which is 33%. So there's an interesting correlation between 1 out of 3 infected dogs having no travel history and 1 out of 3 humans in Erie County being infected without travel history. So again, 2 independent data sets, dogs and humans, indicating that indeed the Lyme disease bacterium does occur in Erie County, specifically here, and that those infections are indeed 1 out of 3 locally acquired.
Wow. So Bill wanted to know what your impression was on the efforts to predict seasonal intensity of tick populations in Lyme disease, because the research that he did seemed to indicate that many of these predictions were at best restricted to localities, so it was hard to generalize the spread of ticks.
The question really boils down to is, are there environmental or other factors that might allow one to predict whether a particular upcoming year is going to be a better or a worse year for Lyme disease infection?
I think so.
There was some work done in eastern New York by Rick Ostfeld at the Carey Institute that shows that there's a pretty good correlation between deer tick populations in association with years of high acorn production. Acorns are often on a 2-year cycle of abundance. Mm-hmm. 1 year you'll be walking on them like they're ball bearings, in oak woods, and then the next year there's maybe very few. Mm-hmm. So those years when there's a high mast crop of acorn production, there's a slight lag the next year when probably the rodent population responds to the great food abundance in the form of acorns by being more fecund and producing more young and a higher mouse population, probably white-footed mouse in particular population, probably would occur the next year. And when you have a high white-footed mouse population, you're going to have potentially more reservoir hosts for deer ticks to feed on. So you would expect a year after that then there to be an even bigger deer tick population. So there is some indication that deer ticks go through roughly 2-year cycles of abundance.
Okay.
That correlate with a lag, correlate with acorn crops.
Wow, that's something that I wouldn't even expect. That's really interesting.
So again, this is where the ecology of Lyme disease gets interesting when it actually starts making sense with features of the environment.
Yeah.
And of course, I would direct you to the paper that Rick Ostfeld published, I think it was in 2006.
Yeah, we'll certainly link that in the episode description for sure.
Yeah, I think that's a very interesting paper. I guess maybe just 2 other things to mention that are maybe more practical in terms of Lyme disease prevention. Again, this is worth repeating. I'm looking at a warning sign that our state health department had helped produce, and it does have the word warning on it, and we try not to be over the top, but we want people to be informed consumers and users of natural areas, but it also has a positive message, and the positive message is to avoid tick bites, wear light-colored clothing, and as I said earlier when we were out in the woods, best to wear light-colored pants and light-colored socks. Also very good to tuck the pant cuffs of those light-colored pants into your light-colored socks so that when ticks crawl up from the ground surface, they're crawling on the outside of your pants where you're more easily to visualize them, find them, and discard them before they can get onto your skin and attach. You might consider using insect repellents, spraying it on your clothing, especially your lower legs. Always follow label directions. And if you are out in tick habitat, especially at the times of the year when the deer tick nymph and deer tick adults are questing, searching for hosts, it's very important to do a tick check once you get back inside, not only for yourself, but if children or pets have accompanied you, they should also be checked. The earlier a tick is found attached to skin and removed, the greater the likelihood of avoiding a Lyme infection. And of course, if you suspect that you have a Lyme infection, for example, the so-called erythema migrans or bullseye rash, an expanding red rash that has a lighter area in the center, like a target, you should definitely consult with your primary care physician as soon as possible and discuss the next step, which could be being placed on a regimen of antibiotic to kill the bacterium that causes Lyme disease. So light-colored clothing, tuck pants in the socks, consider using insect repellent, and tick checks when you come back inside. Very important. These are the practical sides of preventing Lyme disease. The other question that people often raise is, okay, if I have a tick attached, how do I remove it? And there's sort of well-established folklore that the way to remove a tick is to put a lit match or a burning cigarette or Vaseline to suffocate it, or kerosene or gasoline to irritate the tick. And the answer to all that is no, 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 and no. Those are not the proper ways to remove a tick. In fact, those ways can be counterproductive because if you apply intense heat to a living tick, you're going to irritate it and potentially cause it to regurgitate through its mouth parts into the wound, into your skin, into your peripheral circulation. So it's actually counterproductive to either try to encourage a tick to remove its mouth parts by putting heat on it or by an irritant or a suffocant. Forget about that nonsense. The best way is to take a pair of forceps, the finer the tips the better, or tweezers, and grab the tick as close as possible to the point where the mouth parts are attached to the skin, and with gentle upward pressure pull until the tick mouth parts release. And there's a very nice graphic at the website of the U.S. Centers for Disease Control that shows grasping a tick right near the point where the mouth parts attach to the skin, gentle upward pressure pull until the tick releases. Sometimes the mouth parts will break off and stay behind in the skin. And trust me, the size of those mouth parts is so tiny, they're so short, that it's no worse than a tiny wooden sliver in your skin, And you're best just to leave that tiny foreign object behind in your skin. Don't try to dig it out with a needle or a pin or with forceps. Just let nature take its course, and eventually, as the skin sloughs off, those fragments of mouth parts will disappear. So you can do more damage to yourself, create more trauma by trying to remove any broken off mouth parts. So it's not the end of the world if the mouth parts break off.
Okay.
I like to tell this anecdotal story. Back when I worked at the Buffalo Museum of Science, a school field trip came to the museum from Franklinville. It turned out to be in Cattaraugus County. And a young girl who was an elementary school student, as she was riding the bus to the Science Museum in Buffalo, realized she had a tick attached to her armpit. And so when she arrived at the museum, her teacher took her to the security desk, and the security guard called me in my lab at the museum, and I had them come up to my lab, and I demonstrated to the teacher how to grasp the tick with the forceps that I had at hand, and I demonstrated to the teacher how to do it. I would not do it myself for liability reasons.
Oh, yeah.
But I demonstrated to the teacher how to do it, and I timed her. And it took 12 minutes of continuous gentle tugging on the tick, such that a little volcano of skin raised up in the air from pulling the tick with the mouth parts attached in the skin.
Yeah.
It took 12 minutes before those mouth parts released.
Wow.
I immediately put the tick under my microscope, which was right next to where we were sitting, and I told the teacher, "Congratulations. Your patience paid off because the mouth parts were perfectly intact on the specimen." But I should also tell you, in the interest of full disclosure, that tick turned out not to be a deer tick. It was an American dog tick.
Okay, yeah.
And so some ticks maybe are harder to remove than others. As it turns out, the American dog tick is one of the species of ticks that when it feeds on a human, or any host for that matter, it actually secretes what's referred to as a cement-like substance, or just simply a cement, that envelops the piercing part of the mouth parts, the hypostome and chelicerae. And not only do you have these backward-pointing teeth.
Yeah, the hypostome is barbed, so it sticks in you real good and stays in.
This is an amazing graphic, and again, I know that people listening on audio can't see it, but we're looking at what looks like a miniature tongue depressor that has rows of backward-pointing teeth. And it's those rows of backward-pointing teeth, like the barbs of a fishhook, that resist the mouth parts being removed from host skin. So this barbed hypostome is the reason why it's not easy to remove a tick mouth part. But some people have the misconception that somehow the whole tick burrows into your skin. That's not true. It's only the hypostome and the chelicerae, these apical, tiny parts of the piercing mouth parts that penetrate the skin. Just a very small portion of the total body length of the tick actually penetrates your skin, and it's really just these very small, almost needle-like mouth parts that have backward-pointing teeth. And so really, when you're pulling a tick off of host skin on a micro scale, you're literally ripping those backward-pointing teeth against your flesh, and that takes time. And then if you sort of add on this issue of cement being secreted by certain other species of ticks, like the American dog tick, it makes the removal even more challenging, because you're not only fighting the backward-pointing teeth, but you're fighting literally a cement-like substance.
Yeah.
So it's actually amazing how well-adapted ticks are to maintaining attachment to a host when they blood feed, which also begs the question, well, when they're done feeding, how do they drop off of the host? Well, I can only presume that they secrete some kind of chemical that maybe dissolves the immediate surrounding tissue so that the mouth part can be withdrawn without breaking off. Again, that's just speculation on my part, but certainly a tick does have the capability of withdrawing its own mouth part after it's done feeding, because they do drop off onto the ground, a fully engorged adult female, and they're virtually helpless and immobile. I mean, they're so over-engorged that they can't even move. Or barely move.
Yeah.
Okay. And so they stay down in the leaf litter and probably don't move very far the rest of their life, and that's where they ultimately will lay their eggs once they're mature. Do not grasp the tick at the extreme hind end, because you have to think conceptually of that tick. Let's say it's partially engorged. You have to think conceptually of that tick as like a miniature syringe ball. And if you're grasping the bulbous hind end of the tick and squeezing, you're potentially forcing tick body fluids with infectious agent into your peripheral circulation. Mm-hmm. So you always want to grasp the tick as close as possible to the skin surface, gentle upward pressure pull until the mouthparts either release or break off. And then treat the resulting wound with a topical antiseptic and monitor for symptoms. If you become symptomatic, obviously you should be seeing your primary care physician as soon as possible.
Well, I have one last question for you. So, in preparation for this episode, I was doing a little bit of reading on the CDC website, and they were saying how there are many species of ticks, but in terms of the ticks we need to worry about, and not just for Lyme disease, but Rocky Mountain spotted fever and anaplasmosis, babesiosis, they said there's only about 7 or 8 species throughout the entire U.S. that we really need to worry about. Yeah, and in New York, I think we only have about 4 of those.
Yeah, really, in the Northeast, there's really only 4 species of hard ticks, or so-called wood ticks, that you need to be concerned with. And one, of course, one out of the 4 is the deer tick, which is the vector not only for the infectious agent causing Lyme disease, but also babesiosis and anaplasmosis. And more recently, it's been found to be a vector of a flavivirus that causes another disorder called deer tick fever. So there's actually 4 different disease etiologies, if you will, that result from a deer tick bite. But the other 3 species of ticks that are medically important in New York State and the Northeast, one is the Lone Star tick. Mm-hmm. And that tick is not, it does occur in upstate New York, but it's not anywhere near as common as it is down on Long Island.
Oh, okay.
If you go to visit Long Island, especially beach areas or pine scrub areas, the Lone Star tick is quite common there, in fact, almost a pest. The American dog tick historically was one of the 2 most common ticks in western New York, and that certainly is a third tick of concern. And that particular species of tick, the American dog tick, can be the vector of a rickettsial organism that causes Rocky Mountain spotted fever. More collectively, what are called spotted fever, rickettsiosis. The 4th species is called the woodchuck tick, Ixodes cookii. And the woodchuck tick and the American dog tick historically were the 2 most common ticks in western New York, and I think the deer tick is probably taken over now in terms of being more common. But I'm sure these other 2 species are certainly still here. But the deer tick is, in a relative sense, has become more widely distributed and more common. And again, it wouldn't be impossible to find or locally acquire a Lone Star tick in western New York, but not as likely as the other 3 species.
So in terms of the Northeast, are these really the 4 species that we have? Or are these just the 4 species that are going to try to latch onto you and they can actually transfer a disease?
The way to think about it is these are the 4 species that are of primary concern from a medical standpoint.
So this isn't to say these are the only ticks in the area. These are just the only ones that we have to worry about medically.
Medically, that's correct. There certainly are other species of ticks found here. For example, there's a species called the squirrel tick.
Okay.
Ixodes marxi. And so this is yet another reason why you don't want to have red squirrels roosting in your attic or garage or wall voids or whatever, because they can leave their ectoparasites behind. And I have done several identifications of squirrel ticks that were recovered from houses that were infested with red squirrels.
Wow. Okay.
And interestingly, the squirrel tick can be a vector of Powassan encephalitis virus. Yet again, another reason why you don't want to have squirrels roosting in your attic or wall voids or rustic cabins or cottages or whatever. There's another tick-borne disease that's been associated with the squirrel tick as well, and I don't want to get into the details of it, but there's also a species called the beaver tick. There are actually several other species that do occur in New York, but they're not medically important.
Okay. All right, Wayne, thank you so much again. And do you have a website?
No, I'm not important enough.
I wouldn't say that, but...
But if people want specific health information, the CDC or State Health Department websites are very good places to go for more details.
And we'll make sure to link those in the episode description as well. Mm-hmm. Fortune favors the prepared mind. So if you listen to this episode, you should be in a good place to deal with these kind of things.
Absolutely.
Yeah. And again, thank you so much for your time. Incredibly helpful. Thank you very much.
You're welcome.
Well, I hope you enjoyed the bonus episode this month. First and foremost, we'd like to thank our growing list of supporters on Patreon. Like we said last time, this list is getting long, so we're only going to be mentioning our new patrons and our top-level patrons every episode. Thank you so much, Alyssa, Rob, Molly, we named the dog Indy, Bethany, Matt, and especially Scott, Ken, and Diane. You guys all make this podcast happen. So this episode's running a little long, so we'll thank our new reviewers during our regular monthly episode. And by the way, we're at 24 written reviews, and Bill and I said we were going to do something special when we reach 25. So if you've been procrastinating on a review, now's definitely the time to leave one. So if you have any of your own questions, comments, or episode suggestions, send us an email at thefieldguides@gmail.com. Visit us on Instagram at FieldGuidesPodcast, follow us on Twitter at FieldGuidesPod, like and follow us on Facebook, and visit our website at thefieldguidespodcast.com. If you like what you hear and you want to support the podcast, you can do so on patreon.com/thefieldguides. But if you're like me and you can't afford to financially support a podcast right now, there are other ways you can help out. You can share our episode with a friend or rate us and leave a review on iTunes or Stitcher. It really helps get the word out to more people. If you want to read Gerry's article about Wayne or any of the other links mentioned during the episode, they'll all be in the episode notes. Thanks for listening, and we'll see you later this month for our regularly scheduled episode.